Hello everyone, welcome to the session. In this session, we are going to discuss about Byte Order Mark (BOM). This concept is related to Unicode or UTF character encoding only. It is not used in any other encoding schemes like ASCII and SI. Before we jump to the main topic, Byte Order Mark, let me reiterate few things quickly which we discussed in the last session. In last session, we discussed about encoding scheme like UTF-8, UTF-16, UTF-32. UTF-8 encodes the character in 8 bits, 16 encode the character in 16 bits, means 2 bytes, and 32 encode the character in 32 bits, means 4 bytes. Suppose you have character A, you are encoding this character with UTF-8, so the value would be 41 in hex. And if you are encoding character A with UTF-16, the hex would be 0041. So 2 byte. It will convert it into 2 bytes. So it will take 2 bytes. If you are encoding A with UTF-32, it would be converted into 4 bytes. What would be the value? 00 and 41. So 4 byte. You can see UTF-8 is using only single byte. UTF-16 and 32 using more than 1 byte. These called multi-byte encoding scheme because it is taking more than 1 byte for a single character. So let's see what is byte order mark BOM. BOM is the sequence of bytes present in the starting of a file which tells about bytes order of a character bytes and encoding form. The value of BOM bytes depend on the character encoding scheme used at the time of encoding of the text or file as shown in the screenshot. Also, one point to be highlighted is BOM bytes would not be visible when you read particular file or you open particular file. So these are hidden. So what would be BOM bytes value? For particular encoding scheme, we have a predefined BOM bytes value. Like for UTF-8, you will see this value present at the starting of the file when you will see the hex code of the file. Now let me explain BOM with the help of one example. Suppose you want to create one file and the content of the file is A, and you want to save that file with UTF-16 BE encoding scheme. So this is with this encoding scheme you want to save this file. B means big-endian. So what would be the value of this A in the memory? The bits would be started with BOM byte. So for this particular encoding scheme, the BOM byte is FEFF. FEFF. 2 bytes. Then here the hex code of A would be present. So what is the hex code of A? That is 41 single byte. But since we are encoding with UTF-16 and UTF-16 takes 2 bytes, will be first byte would be filled with 00 and then 41. So these are the 2 bytes for character A, and these are the BOM. These 2 bytes BOM. Suppose you are encoding A with UTF-8 BOM. So what would be the value of bytes in the memory? That would be the BOM byte starting with BOM bytes EF, BB and BF. 3 bytes for BOM. Then value of A. As you know, UTF-8 is a 8 bits encoding scheme, so it will take only single byte for particular character. So the value of A is 41. So it would take 41 hex. So this is the value would be present in the memory. When you open the saved file, so what is the value in the memory? This. When you open this, so basically that is the decoding. So when you read or open the file, what would happen? You will see the A. You will not see these BOM bytes in the text editor or these BOM bytes because these are not visible. Now it should be clear what is BOM, how it works. Now let's see what is the use of these BOM bytes. BOM tells two things. First is the border of the bytes of particular character. Second is the encoding scheme. Suppose you have encoded this A with UTF-16 BE, second here, with this. So what would be the value in the memory of this character? F F E F F and then value of A is 0041 in hex. Now this value would be present in the memory. When you will read in particular text editor will read this or decode this, when it will find this, it will understand this is the UTF. This now let's see what is endianness. Endianness is a term that describes the order in which a sequence of bytes or we can say multi-bytes is stored in the computer memory. Now let's see the types of endianness. There are two types of endianness. First is big-endian and second is little-endian. In big-endian, the most significant byte or big end of the sequence is stored first. In little-endian, the least significant byte or little end is stored in memory first. Suppose you have this sequence of bytes 0, 1, 2, 3, 4, 5, 6, 7. If you are storing these bytes with big endian technique, then how it will look like in the memory? In the screenshot you can see in orange color. So at the first place the most significant byte would come, that is 0, 1, then the rest 2, 3, 4, 5, 6, 7. And if you are storing these bytes with little endian technique, then the least significant byte 67 would come first in the memory, as you can see in the screenshot in green color. So first 67, then 45, then 23, then 0, but the order would be reversed. So this is the difference between both these endianness. I will give few more examples on the dashboard. So let's move on to the dashboard. I have taken the Chinese character. Suppose you are encoding this with big endian encoding scheme UTF-16 big-endian. So what would be the BOM byte? FE and FF. And we know the hex code of this byte is, this character is 6F41. So in big endian encoding scheme, at the first place, first the MS most significant byte of the character is stored first. So that is 6, then rest 41. Suppose if you have 4 byte of character, for example this, what will happen? So the most significant is this, so 1, 1, then rest 2, 3, 2, 3, 1, 1. These bytes are stored in the memory. So at the time of decoding, that particular text editor or programming language will check this BOM and will to understand whether it's big endian or little endian. So in this case it is a big endian. The party which is decoding this will keep the order as it is, and we will get the correct character this after decoding. Now let's see the little endian. Suppose you have encoded this data, this Chinese character, using this encoding scheme little endian UTF-16 little endian. So what would be the value? First BOM byte, FF, then FE, then the value of this character. The hex code of this character is 6F41. But in little endian, what happens? First, the least significant byte is placed first. So 41, then it moves from left, right to left, then 65. So in memory, it will look like this. First, the least significant bit, this, then the rest byte. So when this byte would be decoded using particular text editor or any other software, or you can say when you are reading this particular file or this character, at the time of decoding, that particular software or like text editor or any programming language will check this, and it will find that this character has been encoded with this particular scheme, UTF-16 little-endian. So what it will does, at the time of decoding, it will change the order. It will first keep the 6F, then 41, and it will convert it to this Chinese letter. So here you can see the actual order has been retained at the time of decoding, even if in memory the order was different. So this is how the BOM bytes helps. One more example. Suppose you have encoded particular text with this scheme, little endian UTF-16 FE, but that particular text having 4 bytes, that particular character having 4 bytes, and 4 bytes are 42, 11, 23, and 01. 4 bytes. 42, 11, 23, 0, and 4 bytes. So at the time of encoding, what will happen? The most significant byte would come first in the memory. 23, 11, and 42. You can see the order has changed, but when it will be decoded, at the time of decoding, this would be checked. It is, and the software or text editor would find that this is little endian, and I need to take it from this. So it will 42, then 11, 23, and 01, and this would be decoded correctly. Now let's see if endianness concept like big endian or little endian is applicable for UTF-8 or not. This concept of byte order, big endian and little endian, is is applicable for character which are represented with more than one byte. Like in UTF-16, we represent particular character with 2 bytes, 16 bit. In UTF-32, we represent particular character with 32 bits, 4 bytes. So this concept of byte order is applicable for UTF-16 and UTF-32. But for UTF-8, this concept of endian is not applicable, because in UTF-8 we represent particular character with 1 byte. For 1 byte character, there is no possibility of change in the position. There is no possibility of change in the order of the byte. It only happens when character is represented with more than 1 byte. So in UTF-8, these BOM is used just to detect that the encoding scheme is UTF-8. So the decoder will check the BOM, and looking at the BOM, it will understand that this is UTF-8. So here also I mentioned that byte order is applicable when character is represented with more than 1 bytes, like UTF-16 and UTF-32. Byte order has no meaning in UTF-8 because 1 byte is used to represent the character, and there is no possibility of change in the order of the bytes. So in UTF-8, the BOM is used only to identify file has been encoded with UTF-8 or not. With UTF-16 and 32, there is no possibility of without bytes order mark BOM. Means if you are using UTF-16 and UTF-32, then you will have to use the BOM by default. However, in UTF-8, there is a possibility that you could use UTF-8 without BOM. Or if you want, you can also use UTF-8 with BOM. So let's see that. You can encode the file with BOM or without BOM. So you will have the option in few text editor that you can encode your file with BOM or without BOM. If you are encoding file with BOM, the BOM byte at the starting of the file would be present. If you are encoding the file without UTF-8, then BOM byte would not be present. Now let's see how we can visualize byte order mark in Notepad++ using the Hex Editor plugin. Now we will see how we can check the BOM byte order mark in Notepad++ using Hex Editor plugin. You need to click on plugins and you can see Hex Editor at top. Means I have Hex Editor in my Notepad++. The Hex Editor does not come by default in Notepad++, so you will have to install it. How to install the Hex Editor in Notepad+? I have already created one video on this. You can go and check that video. Link in the description of this video. First video where I have explained how to use the Notepad++ with Hex Editor. Once you complete that video, you will be able to see this Hex Editor plugin. Here you can see one file opened which is having one Chinese letter and two English letters. So when you click on the encoding option, you will have few encoding options: ANSI, UTF-8, UTF-8 BOM, UTF-16 BE BOM, UTF-16 LE BOM. So these are the options we already discussed in this video, big-endian and little-endian. So we are going to see that. So let's encode this file with UTF-8. So I have clicked on that option. Now my file is encoded with UTF-8 without BOM. Now let's see the hex code of it. If we see the hex code, then we will be able to understand whether BOM bytes are present or not. On the plugins, you need to hover the Hex Editor and click on View in Hex. As soon as you click on View in Hex, you will see the hex code of those letters. So this is representing the Chinese letter. 41 is for A and 41 for second A. Here there is no BOM byte at the starting of the file here because we have selected the encoding option without BOM. That's why. Again, you need to click on plugins and click on this. So this is the decoded form. Now let's see the option UTF-8 BOM. Means we are going to encode the file with UTF-8 using the byte order mark option. Let's click on it. So our file is converted into UTF-8 BOM. Now click on plugins again and see the view in hex. You might have observed that we have few more hex code in the file, and those are these. So this 41 is for A, this, and these are for from here to A2 for Chinese letter, and these are BOM bytes, byte order model. These are the bits, these are the byte or hex code which I have shown in the screenshot in few previous slides. So this is the BOM against the UTF-8. Now let's see BOM byte for UTF-16 BE, big-endian. The concept we already discussed in previous slides. So now file is converted into UTF-16 BE. Click on the plugins, click on Hex Editor and view in Hex. So this is converted into hex code. So here in big-endian, the most significant byte is stored at the first position. So the most significant byte is 00. 41 is the least significant byte. So this is representing A and this is representing A. So 41 is the hex code for A and this is for Chinese letter, and these are the BOM bytes, the starting of the file. In little endian it would be FFFE. So this is the BOM byte against UTF-16 BE and it is of 2 byte as we discussed already. So this is how you can visualize, you can check the BOM. Let's encode our file with other option, UTF-16 LEBOM. Click on. Since we are using the little endian UTF-16, least significant byte would come first. This is the least significant byte here. In big endian, 41 was after 00, but here 41 is before 00. This is the concept we discussed already. Ignore these 00, these 00s. And this is the BOM bytes for UTF-16 little endian. This saw BOM byte for big endian, that was FEFF. Here it is FFFE. So this is how we can visualize the BOM bytes in Notepad++. That's all for this session. Thanks for watching. See you in the next video.